Hello math students, today's video is lesson 3.4 polynomial connections. In today's lesson we are going to be talking about how we can add, subtract, and multiply polynomials with just the graphs, no equations. We are also going to look at what we get as our answers to see what happens when we add, subtract, and multiply various types of polynomials. So when I am adding or subtracting or multiplying from the graph, one thing that I will often do is I will create a table. I will plug various x values into each function and then add my resulting y values together. So for example, on number 1, I want to do f of x plus g of x. So I have my x values on the left. So I'm going to start with f of x. If I plug -4 in for x, on the graph I have a -7. If I plug -3 in, it gives me a -6. As I keep doing these, this is what I get. I'm going to do the same thing for g of x. I'm going to plug -4 in for x, gives me a -2. I plug in a -3, I'm at -1. At -2, my y value is 0. -1, my y value is 1. At 0, I'm at 2. And then 3, 4, 5, and 6. Once I have this done, I'm just going to add straight across. -7 plus -2 is -9. -6 plus -1 is -7. And then I have a -5, -3, -1, 1, 3, 5, 7. Once I get to this point, I am just going to ignore everything in the middle columns. And I'm just going to look at the -4 and the -9. X equals -4, y equals -9. I then have x equals -3 and y equals -7. At -2, let me get these in the right spot. So -4 was -9, -3 was -7, -2 was at -5, and then I just continue plotting these points. Once I have these plotted, I'm just going to go and connect the dots. And this is f of x plus g of x. Number 2 is pretty much the same thing. F of x is the exact same graph that we had before, so I already have my y values filled in. I'm going to do the same thing for p of x. When x equals -4 on p of x, y equals -7. When x equals -3, y equals -5. When x equals -2, y equals -3, and then a -1, and then 1, 3, 5, 7, 9. So these numbers that I wrote down are the y values on p of x for the different x values. What I'm going to do now is I'm just going to add -7 plus -7. It's a -14. -6 plus -5 is -11. -5 plus -3 is -8. Then a -5. Then a -2. A 1, 4, 7, 10. And now I'm just going to connect. I'm going to plot my points and then connect the dots. So I didn't have space on my graph for x equals -4 and x equals -3. But when x equals -2, y equals -8. When x equals -1, y is at negative 5, and then a negative 2, and then 1, 4, 7, and then 10. To finish graphing, I am just going to connect the dots. Number 3 is the same kind of thing. F of x, once again, it is the same f of x that we had on 1 and 2. M of x, I'm going to write down the y values for the given x values. So when x equals negative 3, y equals 9. When x equals negative 2, y equals 4. At negative 1, y equals 1. At 0, y is 0. When x is equal to 1, y equals 1. When x equals 2, y is equal to 4. At x equals 3, y equals 9. And then I didn't give you any information for x equals 4 and x equals 5. Once again, I'm going to just add negative 6 and 9. That gives me a 3. Negative 5 plus 4 is negative 1. Negative 4 plus 1 is negative 3. Negative 3 plus 0 is negative 3. Negative 2 plus 1 is negative 1. Negative 1 plus 4 is negative 3. And the last point that we have is 0 plus 9 equals 9. We're then just going to go and plot this like we did on number 1 and 2. When x equals negative 3, y equals 3. When x equals negative 2, y equals negative 1. When x equals negative 1, y equals negative 3. When x equals 0, y equals negative 3. X equals 1, y equals negative 1. X equals 2. Y, that should actually be a positive 3. And then x equals 3, y equals 9. So then I go and connect this parabola. And that's my graph for f of x plus m of x. Number 4, instead of adding, we are subtracting. So I have f of x minus h of x. F of x is the exact same f of x we've used on 1, 2, and 3. So I'm going to fill in the points for h of x. When x equals negative 4, y equals 5. When x equals negative 3, y equals 4. And then 3, 2, 1, 0, negative 1, negative 2, negative 3. So once again, these points that I have in the second and third columns, these are my y values at the given x values in my first column. So to find f of x minus h of x, I'm just going to subtract negative 7 minus 5 is negative 12. Negative 6 minus 4 is negative 10. Negative 5 minus 3 is negative 8. Negative 4 minus 2 is negative 2. And then I have, sorry, not a negative 2, a negative 6. And then I have a negative 4, negative 2. Then a 0, positive 2, positive 4. So for these last three, negative 1 minus negative 1 is just adding 1. 0 minus negative 2 is adding 2. 1 minus negative 3 is adding 4. So I'm going to go plot these points. X equals negative 4, y equals negative 12. It doesn't fit on my graph. X equals negative 3, y equals negative 10. X equals negative 2, y equals negative 8. X equals negative 6, y equals negative... x equals negative 1, y equals negative 6, x equals 0, y equals negative 4. Continue plotting all of these points. And then I could continue this pattern. It's just a slope of 2. and that's my graph. When we get to number 5 through 8, instead of adding or subtracting, we are multiplying. F of x and g of x are the same f of x and g of x that we've already used, so I already have the table filled out. So I'm just going to multiply straight across. So negative 7 times negative 2 is 14. Negative 6 times negative 1 is 6. Negative 5 times 0 is 0. Negative 4 times 1 is negative 4. Negative 3 times 2 is negative 6. Negative 2 times 3 is negative 6. Negative 1 times 4 is negative 4. 0 times 5 is 0. 1 times 6 is 6. And then go connect the dots. When x is negative 3, y is 6. When x is negative 2, y is 0. When x is negative 1, we're at negative 4. And then a negative 6. Negative 6, negative 4, 0, and 6. And then connect. This gives me a nice parabola. I redraw that. There we go. Same thing on number 6. I'm going to multiply straight across. Get a negative 35, negative 24, negative 15, negative 8, negative 3, 0, 1, 0, negative 3. So the first point that actually fits on my graph is x equals negative 1. So at negative 1, I'm at negative 8. Negative, or 0, I'm at negative 3. 1, I'm at 0. 2, 1, 0. And then because of the symmetry of the parabola at 5, it is going to be back down at negative 8. That's my graph. Same kind of thing on number 7. Multiply across. I get a negative 10, negative 4, 0, 2, 2, 0, negative 4, negative 10, and then negative 18. Put this on my graph. Negative 3 is negative 4. Negative 2 is at 0. 2 is, or negative 1 is at 2. 0 is at 2. Back to 0. And then negative 4. And then negative 10. So 1 and 2 and number 4, we're looking at adding and subtracting linear functions, and then number 3 was looking at adding a quadratic to a linear. So hopefully we noticed on 1, 2, and 4 that when we added or subtracted to linear functions, we ended up with a linear function. And then when we added a linear function to a quadratic, my answer on number 3 was another quadratic. Five through 8, we were multiplying polynomials. So when we multiplied two linear functions, so that was 5 through 7, we ended up with a quadratic function. On number 8, I multiplied two linear functions. We ended up with what is called a cubic function. This is just a function that has degree 3. Another thing we hopefully noticed was with the x-intercepts. The x-intercepts on my original graphs are at the same points as the x-intercepts on my new graphs when I'm multiplying. So I'm going to say the x-intercepts stay the same when multiplying functions. And then for the end behavior, on number 5, both of my ends went up. If I look at the end behavior on my original graphs, on the left, both ends went up. Sorry, on the right, both ends went up. On the left, both ends went down. Positive times positive equals positive. Negative times negative equals positive. Similar thing on number 6, except for on the right, f of x goes up, but h of x is going down. Negative times positive equals negative. On the left, h of x is going up, f of x is going down. Positive times negative equals negative. On number 7, same kind of thing. Positive times negative, negative. Positive, negative times negative, it gives me a negative. We also have the same kind of thing happening on number 8. On the right, g of x and f of x are going up, but h of x is going down. Positive times positive is negative. On the left, h of x goes up, the other two go down. Positive times negative equals positive. So I could say for the end behavior in multiplying, you can just multiply the end behavior. And we're just looking at the signs. So multiply the end behavior of the original graphs.